Right, paper number 17, question number 1. Weekly paper number 17, question number 1. Given there, fx, x squared plus kx plus k. Fx is x squared plus kx plus k, where this k is a real, right? Alpha and beta be the roots of fx equals 0. Fx equals 0 mean fx is this, no? X squared plus kx plus k equals 0. Now this is a quadratic equation, no? In that quadratic equation, the two roots given as alpha and beta, right? Okay, here the two roots of this are alpha and beta. Asking to show that alpha plus beta minus k and alpha beta k. Right, so then here fx equals 0 means this, its roots alpha beta mean when you put alpha for the x, alpha squared plus k alpha plus k equals 0. Right, so that means when x equals alpha mean, right, x equals alpha is a root mean x minus alpha should be a factor, also x minus beta should be a factor. So therefore, two factors of this fx we can write as what? X minus alpha and x minus beta, right? So then I can do it like this. Since alpha is a root of this, we can write, right? When I put alpha for this x, we get alpha squared plus k alpha plus k equals 0, right? This means, right, when I put here for x alpha, alpha squared plus k alpha plus k, that's what here we have. It means it equals 0 means f alpha 0, right? F alpha 0. F alpha 0 means x minus alpha should be a factor of fx, right? Right? Therefore, x minus alpha is a factor of fx, right? Similarly, we can put beta here. Beta is the root of this, no? Beta squared plus k beta plus k equals 0. That means when I put here beta, that thing f beta, no? F beta is 0. Then in the same way we can say similarly x minus beta is a factor of fx, right? Therefore, fx has two factors and fx is a quadratic one. Therefore, fx we can write, therefore, we can write fx as how? X minus alpha into x minus beta, right? Here we must write lambda. Lambda is a real number. Okay, lambda is a real number, right? But now this fx is really this. Then I can substitute this fx here. We get x squared plus kx plus k is equal to lambda times x minus alpha, x minus beta, right? I can now simplify the right hand side. X squared minus alpha plus beta times x plus alpha beta we get. Left hand side we have x squared plus kx plus k. Now x squared coefficients you can equate. One to this, we get lambda x squared, coefficient is lambda. Left hand side 1, lambda equals 1. X coefficient will equate now, remove the bracket, minus lambda times alpha plus beta. Left hand side it is k, but lambda equals 1. This gives us alpha plus beta is minus k. And x to the power 0 coefficients are constants, lambda into alpha beta. Left hand side it is k, but lambda is 1, therefore alpha beta is k. This way we can write the first two answers. Right. Next one asking, number 1, if k less than or equal to 0 or k greater than or equal to 0, show that alpha and beta are real. Right. Now alpha and beta are the roots of this x squared plus kx plus k equals 0, no? Right. So then first we'll take that quadratic equation x squared plus kx plus k equals 0, right? The nature of the roots of a quadratic equation is given by its discriminant delta, right? So then we can write delta, right? Delta is b squared. B means kx coefficient. B squared minus 4 times a into k, right? This is the delta. So then delta is k squared minus 4k, right? Right. You know, when the roots are real, delta greater than or equal to 0, right? Now you can write when the roots are real, delta greater than or equal to 0, right? So delta, I can write k squared minus 4k greater than or equal to 0, k times k minus 4 greater than or equal to 0, right? So then I can find the range of this. Here k value 0, here k value 4. Since here we have equal sign, both 0 and 4 we have to select. Okay. Now when I substitute, like k equals 1, 1 minus 4 within bracket minus 3, here 1 into minus 3 is minus 3, then we get to the left hand side minus 3 greater than or equal to 0 means false. So therefore the interval 1 lies between 0 and 4, no, that interval does not satisfy. This does not satisfy, this therefore should satisfy, this therefore should satisfy, right? So therefore we can write for value of k less than or equal to 0, or k greater than or equal to 4. This is the range. This is the range. That's how we take that answer. Right. Next one, if k greater than or equal to 4, show that alpha and beta are negative, right? Now we can say it like this. Next part. Right. When k greater than or equal to 4, right? In this case, when we take, right, you know, alpha plus beta we found, right, is equal to minus k. Then this k 4 or greater than 4. Anyhow, this is positive because k greater than or equal to 4 means this k is positive. But before it we have minus sign. Then this right hand side complete answer is negative. That says alpha plus beta answer is negative. Similarly, when you take alpha beta is k. Since this k is greater than or equal to 4, this is positive. Therefore, alpha beta positive. Okay. Now, alpha and beta are two real numbers. Their sum is negative. Their product is positive. There are two real numbers, right? Their sum is negative. Their product is positive. Definitely, that two real numbers should be negative. Understand? Sum negative, product positive means the two real numbers should be negative. Therefore, you can say hence alpha negative and beta negative. Right. This way we can show both roots negative, right? Okay, now asking find the quadratic equation in terms of k whose roots are mod alpha and mod beta, right? When we have a quadratic equation, right, when you are given the two roots of quadratic equation, we know how to write the quadratic equation, right? The two roots given now, this mod alpha and mod beta, mod alpha and mod beta, mod alpha and mod beta are the two roots. We need to find the quadratic equation with mod alpha and mod beta as the roots. Then how to write? When you are given the two roots, the quadratic equation we can write x squared within the bracket sum of the two roots times x. Next one, product of the two roots equals 0. This is how we write the quadratic equation when the roots are given, right? Then I can write this one furthermore, mod alpha plus mod beta times x. Here, mod alpha into mod beta we can write as alpha beta mod like this, equals 0, right? This is suppose star, right? Now I am going to find this separately and this separately. Then we can substitute, okay? This mod alpha plus mod beta I can find like this, mod alpha plus mod beta. I first square this. Then we get mod alpha squared plus 2 times mod alpha mod beta plus mod beta perfect squared, right? Mod alpha squared is equal to alpha squared. Mod beta squared is equal to beta squared, right? Here you can write this as alpha beta mod. And furthermore, you can write this alpha squared plus beta squared like this, alpha beta perfect squared minus 2 alpha beta plus 2 times mod alpha beta. Okay. Alpha plus beta is really here minus k. Then this is minus k perfect squared minus 2 times alpha beta is this k, right? You can very clearly understand here alpha beta is k, right? But k value is greater than or equal to 4. K value is greater than or equal to 4. That means k is positive. K is positive. When k is positive, its modulus is the same k. Why? Because we know when the real number is positive, its modulus is, right, the same real number. So therefore, this is minus k perfect squared is k squared minus 2k plus 2k. These two you can cancel down. Here we get k squared. It is in the left hand side, mod alpha plus mod beta perfect squared. Then take the square root on the right hand side, right? So then we get k. Therefore, mod alpha plus mod beta is equal to, there we must not write positive or negative because we know mod alpha is a positive value, mod beta is a positive value, sum of two positive values is positive. K also positive, therefore, point of putting this minus sign, just right now, no mod alpha, mod beta, sum. Then we can put that here. Mod alpha beta is really k. Then we can write the equation with the roots mod alpha and mod beta. Okay. Therefore, you can write by star, we can write by star, we get x squared minus mod alpha plus mod beta mean here now k, kx plus alpha beta mod means equals 0. This is the required equation. As a required equation, right? Okay, now we'll come to question number 2. Okay, question number 2 says state and prove the remainder theorem. What is remainder theorem? Remainder theorem. What is that? When fx is divided by, right, x minus a, right, the remainder is fa, right? This is the remainder theorem. Ask you to prove that. We prove it like this. We assume this way. When this fx is divided by x minus a, I am going to assume the quotient as hx and I am going to assume the remainder as r. Okay? Then you have to first write how. Let us assume when fx is divided by x minus a, the quotient is hx and remainder as r. That way we have to write the statement. Then division algorithm. So algorithm of division we may write this fx by algorithm of division. We can write how fx is equal to x minus a into hx, right, plus r. This r is a real number, constant. It doesn't contain x, right? Reason when we divide fx by x minus a, the device is degree 1. Therefore, definitely the remainder should be lesser degree than divisor. Then remainder should have the least degree polynomial function can have is 0. 0 degree polynomial function means real number. So that's why we say r doesn't contain x, right? So now put here x equals a. Then here we get fa, right? A minus a ha plus r. We know this is 0. Then the product will be 0. R equals fa. Therefore, R equals fa. Hence, the remainder is fa. Remainder is fa, right? Our next part. A quadratic polynomial px has remainder 6 to 1, right? Px is a quadratic polynomial, right? Quadratic polynomial, second degree polynomial, right? A quadratic polynomial px has remainders 6, 2 and 1 when divided by x minus 1, x minus 2, x minus 3, right? Then, you know, when px is divided by x minus 1, the remainder we can write as p1. When px is divided by x minus 2, the remainder we can write as p2. When px is divided by x minus 3, remainder we can write f3, p3. Right? Px we divide by x minus 1. According to remainder theorem, we can write remainder as p1. When this is divided by x minus 2, remainder you can write as p2. When this is divided by x minus 3, remainder we can write as p3. So, the respective remainders are given as 6 to 1 like this. Right? P1 should be 6, P2 should be 2, P3 should be 1. Right? Show that x minus 1, x minus 2, x minus 3 are factors of the polynomial qx. Right? Qx function is defined like this. Right? Qx function is defined like this. Qx is defined to be x into x plus 1 px minus 12. Minus 12, right? Okay, now we put x equals 1 here. We put x equals 1. Then we get left hand side q1. Right? Then here 1, here 2. 1, 2, p1 minus 12. 1, 2, p1. P1 is 6, no? 1 into 2 into 6 minus 12. Here 12, here 12, 0. Right. Q1 0. Q1 0 means no remainder when Qx is divided by x minus 1. Understood? So therefore, x minus 1 should be a fact of Qx according to factor theorem. Right. Therefore, x minus 1 is a fact of Qx. Right. Put x equals 2, we get Q2. 2 into 3 into P2 minus 12. 3, P2 is 2 minus 12. Here 12 minus 12 0. Then we can write, therefore x minus 2 is a factor of Qx. Right? Third one, we put x equals 3 here. We get Q3. Q3 is 3 into 4 into P3 minus 12. 3 into P3. P3 is 1 minus 12. Here 12 minus 12 0. Therefore, we can say x minus 3. Therefore, x minus 3 is a factor of Qx. Right? Therefore, so far we have found, right, 3 factors of Qx. But you can very clearly understand here x into x plus 1 is second degree polynomial. Px is quadratic, second degree polynomial. Here second degree x into x plus 1 second degree polynomial, Px also second degree polynomial. When you multiply two second degree polynomials, that product will give us fourth degree polynomial. That means this Qx should be a fourth degree polynomial. Therefore, the Qx should have 4 linear factors. Right? But here we found 3 linear factors, x minus 1, x minus 2, x minus 3 as the factors of Qx. Therefore, Qx should have another one more linear factor. So therefore, I am going to write let we write Qx. How? The product of the factors we found, right, into another one factor, like, okay, I'll take it as alpha x plus beta. Okay, where alpha beta are 2 real numbers. Okay, Qx is 4th degree. Therefore, it should have 4 linear factors. We found 3 linear factors. Therefore, it should have another one more. That is the one I assume as alpha x plus beta. Alpha and beta are 2 real numbers. We have to evaluate them. So, let's see how to evaluate them. They can be evaluated like this. I can substitute for this Qx, right, this. Then what we get there? X into x plus 1 Px, x into x plus 1 Px minus 12 equals here x minus 1, x minus 2, x minus 3, alpha x plus beta. Right? So then, right. Now put x equals 0. When put x equals 0, when you put x equals 0 here, right, this whole thing will be 0, even minus 2 in the left hand side. Right? Then x equals 0 brings here minus 1, minus 2, minus 3, here beta. Minus 1, minus 2, minus 3, right, and beta. What do you get there? Here plus 6 and minus 1, minus 6 beta. Here minus 12, right? So, can cancel down minus signs. Beta is 2. Beta is 2, right? We get beta as 2. Now we need to find this alpha. To find this alpha, we'll substitute x equals minus 1. Why? Because at x equals minus 1, again this bracket becomes 0. Thereby we can evaluate that alpha, right? Put x equals minus 1. X equals minus 1 when you put right. When you put x equals minus 1, here minus 1 plus 1, this bracket will be 0. When this is 0, the entire product, this will be 0, given in the left hand side minus 12, right? Right. Right hand side, when I put x equals minus 1, here minus 2, here minus 3, here minus 4. Minus 2, minus 3, minus 4. Minus 2, minus 3, minus 4. And x minus 1 brings here minus alpha plus beta. Minus alpha plus beta, right. So here minus minus plus and this minus minus and here minus, the all minus signs left and right you can cancel down. 12 is equal to here 2 into 12 and inside the bracket minus alpha, beta we found 2. This 2 also we can cancel down, here we get 1, right. So then 1 equals minus 2 alpha plus 4, right. Now when you remove the bracket, bring this here 2 alpha 3, alpha is 3 by 2, okay, alpha is 3 by 2. Now we have substitute for alpha and beta, then really we get what? This qx, no? Therefore you can write the final answer of qx, hence qx. Hence qx, what? X minus 1, x minus 2, x minus 3, alpha 3 by 2x, 3 by 2x, beta plus 2. Okay. Then we can keep the answer here, or else here take in common limit as 2. This we can write as 4. Then this 2 you can write before like this. Ux is equal to half x minus 1, x minus 2, x minus 3, 3x plus 4. Okay, this way we can find qx. Question number 3 is the next. Right, question number 3 says a cylindrical cavity is formed inside the solid hemisphere of radius a. The axis of the cylinder is along the axis of the hemisphere. Let the radius of the cylinder be x and the height be y. Find the relation between x and y, right? You see we have draw the cylinder, axis of the cylinder and the axis of the hemisphere being the same, coincident. You see, right? Then here we are given the radius of the cylinder as x. This is x. This is x. Right. Height of the cylinder as y. This is y. Right. Radius of the hemisphere as a. Its center here. Therefore, radius should be this length, no? You see. It is a. Here 90. Right. Therefore, the first thing we can obtain, find the relation between x and y. X and y relation can easily be obtained here. X squared y squared is equal to a squared, right? Right. The relation between x and y by applying the Pythagoras theorem, x squared plus y squared is equal to a squared number 1. Okay. Okay. Now show that the volume V of the cylinder is given by volume of a cylinder is base area into height. The volume given as V. V is pi x squared y. Base area into height. X squared can be subjected taking this y squared right hand side. V is equal to pi times x squared. Take this y squared right hand side. A squared minus y squared into y. Then we get right in here pi y. A squared minus y squared this here. Okay, now asking show that the volume V is maximum when y equals this. Right. Then you can see this volume V is a function of y. Therefore, we can differentiate this V with respect to y, and we can find dy over dy, dv over dy, dv over dy. Right? Dv over dy we can write. Pi, once I bring here, we get a squared y. Then a squared is a constant. Derivative of y with respect to y is 1. This y and y squared gives us y cube. Y cube derivative with respect to y is 3 y squared. Dv over dy. So, I can take this minus 3 out. Minus 3 times pi. Then here we get y squared minus this a squared should be divided by 3 like this. Then dv over dy we can write minus 3 pi. Here you can factorize this. You can write this as a over root 3 perfect square. No? Then this becomes difference of 2 squares, right? Then the factor is going to be y plus a over root 3 into y minus a over root 3. Right. So now you know, right, when V is maximum or minimum, you know dv over dy 0. dv over dy 0. No, I can write it here. Right. Then dv over dy 0 means this should be 0. It means minus 3 pi y plus a over root 3 into y minus a over root 3 is equal to 0. But you know, this part cannot be 0. Y is a positive value, A is a positive value. This is completely negative. Therefore, the product of be 0, this should be 0. Y minus A over root 3 should be 0. Y equals A over root 3, right? Now, we have to show at this value of Y, V is maximum. That can be done by using the first derivative sign. Right, now, dV over dy, its sign, I am going to first show when y less than a over root 3, right? So, dV over dy expression is this. You know, the whole thing from here to here, this is positive, pi positive, 3 positive, but since here we have minus sign, this is negative, right? This term is always negative. Now, once I put for this y, a value less than a by root 3 means I am going to put for this place a value less than this. Then this difference will be negative. This negative and this negative together positive. So, therefore, this is positive, right? So, now secondly, I am going to find dV over dy, the sign y greater than a over root 3. Here when you put for this y a value which is greater than this difference is positive. That positive, this negative make negative, no? Therefore, we have what? These two together says us before positive and after that negative we have this here. Therefore, when y equals a over root 3, v is maximum. Right? Therefore, you can write. Therefore, when y equals a over root 3, v is maximum. This way, we can complete the question. Right. Next question number 4. Okay, fourth one. Solve cos 2x sin 3x in the range x minus 92 plus 90. Cos 2x is equal to sin 3x. Asking to solve this in the interval minus pi by 2 x plus pi by 2, right? Okay, we can solve it like this. We can write right hand side. So, sin 3x as this one, cos 2x sin 3x I can write cos pi by 2 minus 3x. Then we have cos equality, 2x equals 2 n pi plus, so minus pi by 2 minus 3x, right? We take plus sign first, 2x, 2n pi plus pi by 2 minus 3x. Bring this 3x to this side, then we get 3x and this 2x, 5x. Subject x, dividing by 5, 2n pi divided by 5 plus pi by 10. N is integer, right? Right. Circle take minus sign and take another solution. We will take minus sign 2x is equal to 2n pi. Take minus sign here. Multiply this minus pi by 2. This minus plus 3x, right? Then I can take this 2x right hand side, these two terms left hand side. Then we get x equals pi by 2 minus 2n pi. Here also n is an integer, right? Okay, now if I take this as solution set number 1, this as solution set number 2, by giving some integral values for this n, you can find the x, but that x should be in the interval between minus 90 and plus 90. Okay, so therefore, when I first put x equals 1 here we get 2 pi by 5 plus pi by 10. Right, pi by 5, when you put n equals 1 here, 5 by 5, 36 into 2, 72, 5 by 10, 18, right? Then 72 plus 18 means 90. That means one solution for x is 90. Huh? One solution for x is 90. Right, x is pi by 2 first. Put x equals, n equals 0. 0 also integer, no? Pi by 10. Another one coming pi by 10. Right? Pi by 10. Pi by 10 is 18 degrees. That also in the interval minus 90 to plus 90, no? When you put n equals minus 1 here, n equals minus 1, right? Then we get x minus 2 pi by 5 plus pi by 10. Okay. Here, minus, when you simplify this, take in common denominator as 10, minus 4 pi plus pi, minus 3 pi. Then here minus 3 pi by 10 we get. Pi by 10, 18 degrees, into 3, 54, with minus sign before, minus 54. That is in the interval, minus 90 plus 90, right? So in the set number 2, when you put some values, suppose for instance in 0, pi by 2, this solution we get. N equals 1 really, right? We get certain solution, but that is not in the interval minus 90 to plus 90. So therefore, by this 1 and 2 sets, when we find x values by giving different integral values for n, this all, this 2 and this all, we get solutions for x, so that in the interval this. Therefore, only 3 solutions, right? And then we can write the solutions are 3. Hence, we can write, therefore, the 3 x values are 3. Therefore, x has 3 answers, pi by 10, that means 18 degrees, pi by 2, 90, minus 3 pi by 10 means minus 54 degrees. They are the 3 solutions, right? For the equation, this in between minus 90 and plus 90, okay? Right, so then we will come to next part in it, given us. Right. Now the next part is, ensure that 1 sin pi by 10 and minus sin 3 pi by 10 are the roots of the equation 40 cube minus 2t squared minus 3t plus 1 equals 0. Okay. Then what I am going to do is, the initial equation cos 2x is equal to sin 3x. Right. Now this equation we have already solved for x. Then we get 3 answers like this here. Right. For the angle x we solve this equation. Now secondly I am going to solve this same equation for sin x. For sin x means what? To get the answers for sin x. How? Like this. 2x we can write 1 minus 2 sin squared x. Sin 3x you can write the sin x minus 4 sin cube x. Now I can take all the terms to left hand side. Then 4 sine cube x will be positive minus 2 sine squared x minus 3 sine x plus 1 equals 0. This way we can write. Now I substitute for sine x t. Let sine x equals t. Then we get what? 4 t cube minus 2t squared minus 3t plus 1 equals 0. Right. Now I am going to find the solution for this t by solving this, right? A cubic equation. This is third degree polynomial in t. Okay. So therefore, I can solve this equation and we can find 3 answers for t. The 3 answers of t mean t equals sin x, no? 3 answers for sin x, right? First we'll take the 3 answers for t, then t is sin x, then for sin x we get 3 answers, okay? Right, so then I can factorize this. You know, when I put t equals 1, what will happen? Here 4, here minus 2, here minus 3, here 1. When you put t equals 1, t equals 1, 4 minus 2 minus 3, 1. The left hand side becomes 0. That means this polynomial function of third degree in t, when you put t equals 1 becomes 0, mean t minus 1 is a factor. Then I can first factorize here. This how? We can factorize this, right? T minus 1 is first factor. Second factor should be quadratic 1. All right. 40 cube available, no? Then it should be 40 squared here. Then only this and this product will give us 40 cube. Here we have plus 1, no? Since here we have minus 1, here we have to have minus 1. Here I take the next one as bt. B only we need to find. B can be found like this. Here, the same expression only we suppose right here. Right, so therefore, in this t squared coefficient should be equal to in this t squared coefficient. Right. In this t squared coefficient is minus 2. In this product, t squared coefficient I can find t squared coming in 2 ways. This and this when you multiply we get bt squared coefficient is b. This and this when you multiply we get minus 4. Then taking this side we get b is 2. Right. Then this unknown we have b. Therefore, I can rewrite this how? T minus 1, right? 4 t squared plus 2t minus 1 equals 0. Okay, right. Then I can write like this. We found the solution of this equation for x. We got 3 answers. I write them here. The 3 answers are pi by 10, right? And other one pi by 2, and other one minus 3 pi by 10. Okay. Now, here I am going to find the solution for this, right? T minus 1, right? 4t squared plus 2t minus 1 equals 0. Then we can equate this to 0. 4t squared plus 2t minus 1 equals 0. Right. Now, people, here we get t equals 1. Here, this is a quadratic equation in t. We can take 2 answers for t. Right. How? We'll apply that quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac divided by 2a, right? Okay. Here a is 4, b is 2, c is minus 1. Minus b minus 2 plus or minus square root b squared 2 squared 4 b squared minus b squared minus 4 a c minus 1. Right? Divide by 2 times a, 2 into 4. T equals minus 2 plus, so minus square root. Here plus 16 plus 4 plus 20. Here 8. Okay. 20 is 0.5. The root is 2 root 5. T equals minus 2 plus, so minus 2 root 5 over 8. Okay. Okay, now I can summarize this solutions like this. Then here we have two answers for t. When I take minus sign, I will first cancel down this by 2. Then we get minus 1 plus, so minus root 5 divided by 4. Right. Okay. There are two answers here. Take plus sign. Then we get root 5 minus 1 divided by 4. Take minus sign. It is minus 1 minus root 5 divided by 4. Right. Now, people, if I summarize this, two methods of solving this, right? Right, now here this is equation, this is the equation. First we solved for the angle x, then we got 3 angles, right? The same equation we solved, but not for x, for sin x we solved. Then sin x has 3 answers. The 3 answers are the answers of t. One is 1, other is this, other is this. Therefore, question asking to show this way, 4t cube minus 2t squared minus 3t plus 1 equals 0 means this equation. Right, its solutions only we found here. 1, this, because t is sin x, no? Therefore, you can say the equation this only in terms of t in the question given, its solutions are the values of sin x, right? Values of sin x. But you know, here sin x 1. Sin x equals 1. Here t is sin x, no? Sin x equals 1. People, now for sin x to be 1, you know x. That x answer only, people, earlier we found as pi by 2. Okay? Alright. Secondly, second answer of sin x is this. This is root 5 minus 1 by 4. This is a positive value. For sin x to be this, root 5 minus 1 divided by 4, there is a certain angle, no? For x. That angle should also be available among these 3. It should be this pi by 10. Because why? This is a positive value. Pi by 10 is sin 18. It is in the first quadrant. Therefore, it should be positive. So, therefore, the next solution of this is what? Sin pi by 10. Another one here we have. It is completely negative. T is sin x, no? Okay. Sin x. Right? Minus root 5 minus 1 divided by 4. This is completely negative. Then there should be a certain x value. X means an angle. That angle should also be among these 3. Then that is this. Therefore, the solutions of this equation should be, first one, 1, other one for this x is pi by 10, then sin pi by 10, other one should be sin minus 3 pi by 10. Then you can write, therefore, the solutions of 4t cube minus 2t squared minus 3t plus 1 should be equal to what? Is 1 and sine pi by 10 and sine minus 3 pi by 10. But you know, when we have minus sign inside the angle, with sign having before, this minus sign you can take out. Then this one you can write as minus sine 3 pi by 10. Right? That is what? 1 sine pi by 10 minus sine 3 pi by 10 are solutions. Are solutions of this equation. I'll take this as star. Star. Okay. And asking finally sine pi by 10. Then people, sine pi by 10 should be this answer, no? Why? Pi by 10 is 18 degrees. 18 degrees sine should be positive value. Right? This is negative, therefore this is only positive value. This can't be the sine pi by 10 value because we said what? Sine x becomes 1 when x equals pi by 2. Then this should be the answer of sine pi by 10. Therefore, sine pi by 10 should be is equal to this root 5 minus 1 divided by 4. Okay, this way we can take that answer. Right, no?